Hello, everyone. Did you know that you could prove two triangles are similar without having to measure all of their sides and all of their angles? In fact, there are just three simple shortcuts. Whether you are an artist that's designing a perspective drawing or a scientist that's scaling up a model, triangle similarity plays a crucial role in problem solving. The three simple shortcuts are angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Now, before we jump into the criteria, let's get one thing straight. Triangles are similar if their corresponding angles are congruent and their sides are proportional. Congruent angles, proportional sides. Unlike congruent triangles, which are identical in size and shape, similar triangles have the same shape but different sizes. Their sides are just scaled versions of each other. First up, the angle-angle similarity theorem, or simply AA similarity. This one's a game changer. If two angles of one triangle match two angles in another triangle, then the triangles have to be similar. So in our example, we see angle A is congruent to angle F. We also see that angle B is congruent to angle G. So if I know this angle and this angle, I can calculate the missing angle by adding these two, A and B, and subtracting it from 180. So if A and B is congruent to F and G, this third angle has to be the same. So C and H have to be congruent. So in our example, we are told if angle A is congruent to angle F and angle B is congruent to angle G, then we don't have to worry about these third angles. We can just make the conclusion that triangle ABC has to be similar to triangle F. Now let's talk about side-side-side similarity, or SSS similarity. If all three sides of one triangle are proportional to the corresponding sides of another triangle, then the two triangles have to be similar. So in our example, we have triangle ABC and DEF. You'll notice the side lengths, AC is 6, then we have 8 and 10. Here we have 3, 4, and 5. I marked the corresponding sides. You see the purple matches the purple, the blue matches the blue, and yellow matches yellow. So I wrote the proportionality statement saying that DE goes over AB, EF goes over BC, FD goes over CA. If I substitute in the numbers, DE is 4, and 4 goes over AB, which is 8. EF is 5. 5 goes over BC, which is 10. And then FD is 3, which goes over CA, which is 6. And if you notice, what happens is this simplifies to 1/2, this simplifies to 1/2, and this simplifies to 1/2. So with all of them equaling 1/2, you know that this is proportional. All sides are proportional. Therefore, we can say that triangle ABC has to be similar to triangle DEF by side-side-side similarity. Last but not least, we have side-angle-side similarity, or SAS similarity. If two sides of one triangle are proportional to two sides of another triangle, and that included angle right here would be the included angle is congruent, then the triangles have to be similar. And so in the example, we see that DE, which is here, corresponds to AB, which is here. I know that EF corresponds to BC, and if I make a proportion out of those side lengths, if that proportion is true, if those two ratios are equal, then you know the sides are proportional. Then if you look at the included angle, and the included angle is the angle that lies between those two sides. So it's this angle here and this angle here. And so if I know that those angles are congruent, so if I know that angle B is congruent to angle E, and that these sides right here are proportional, then I can make the statement that these two triangles have to be similar. So triangle ABC is similar to triangle DEF because of side angle side similarity. Just like we have the congruence properties for triangles, we also have similarity properties for triangles, and there are three of them. The first is the reflexive property, the second is symmetric, and the third is the transitive property. And these are called the properties of similarity. So it basically says that every triangle is going to be similar to itself. So if I have a triangle ABC, I can say triangle ABC is similar to triangle ABC. Now, you know that they would also be congruent because it's the exact same triangle. So the K value here would be equal to 1. But those triangles are still similar, okay? Then we move on to the symmetric property. The symmetric property says if I have triangle ABC similar to triangle DEF, then I can go backwards and I can say that triangle DEF has to be similar to triangle ABC. Our third property is the transitive property. And this is a pretty cool property. It goes, if ABC is similar to DEF, and then we have DEF similar to GHI, I can sort of cut the DEF out and go straight from ABC to GHI and say triangle ABC has to be similar to GHI. So the conclusion right here, triangle ABC is similar to triangle GHI. Let's do a quick recap on what we just covered. We talked about angle-angle similarity, and it tells us that if two angles are congruent or they match, then the triangles have to be similar. Side, side, side says if all three sides are proportional, then the triangles have to be similar. Side angle side similarity says I need two sides that are proportional, and that included angle between those two sides, they have to be congruent. If those angles are congruent and the sides are proportional, then the triangles are similar. Now, triangles might seem simple, but they hold the key to unlocking real-world problems in architecture, design, engineering, and even digital animation. They help engineers design bridges. They let cartographers scale maps. And they even make sure that CGI in movies looks realistic. So whether you're scaling up a blueprint or analyzing a shadow or mapping out a video game world, triangle similarity is everywhere. So next time you see two triangles that just look the same, please remember that math gives us the tools to prove that they are similar. So keep questioning, keep exploring, and most of all, keep thinking like a mathematician. You guys are great. I look forward to seeing you in the next video. Have a wonderful day.